scientifiche di Trieste Città della Conoscenza e le istituzioni che hanno collaborato con noi. Il main partner del festival, i partner e i content partner della manifestazione per il contributo fondamentale. Grazie anche ai media partner e ai partner tecnici. Infine, un grazie speciale ai 200 volontari di questa edizione. Un'ultima nota. Vi ricordo che il prossimo incontro avrà una durata di 75 minuti. Gli ultimi 15 minuti saranno dedicati alle vostre domande. Ricordatevi anche di controllare il programma aggiornato degli eventi su www.tristenext.it, al quale potete accedere anche da questo codice QR. Buon ascolto e buon festival!
Good morning, everybody. I'm Lory Crocè. I am an associate professor of this university in gastroenterology, and it's my great pleasure to introduce today's speaker, Dr. Mauro Giuffrè. He's a distinguished researcher at the Yale University. Dr. Mauro Giuffrè completed his medical fellowship in gastroenterology right here in Trieste before pursuing a PhD in applied data science and artificial intelligence. What sets Dr. Giuffrè apart is unique interdisciplinary approach, working not only in theoretical research, but also applying engineering principles to tackle real-world challenges at the intersection of medicine and artificial intelligence. Dr. Giuffrè has authored more than 60 research articles and is internationally recognized as one of the leading experts in the application of large language models to gastrointestinal diseases. His groundbreaking work continues to shape the future of AI in healthcare, and we are truly fortunate to have him with us today. Please join me in welcoming Dr. Mauro Giuffrè. Mauro, it's your time.
Good morning, everyone. First of all, let me thank Professor Crocè, one of my previous mentors, for the kind introduction. And before starting our conversation today, I want to just provide some information, as Professor Crocè just said, about my background. So I'm a medical doctor, I'm a gastroenterologist, and I also have training in applied data science and AI. So for that reason, I'm a particular figure that works at the intersection between medicine and healthcare. So today I want to talk to you about what large language models are, what are possible applications in my field, so digestive diseases, and also what are the challenges that we're facing now, and also why it is important to know about them and how they may shape the future of healthcare in the next couple of years. So I think that everybody of you during the past few days have heard about artificial intelligence. And just to start with some very basic knowledge, AI is a branch of computer science which is concerned with to create systems that are capable of performing tasks that typically may require human intelligence. And within the AI definition, there are different fields of, for example, machine learning, in which you have data-driven training of models to recognize some patterns or to make prediction. Within the machine learning, you have other subtypes in which you have deep learning. Deep learning is a particular type of machine learning where you use neural networks. And within the deep learning, you have some subfield of generative AI, in which you use artificial intelligence not only to make predictions, but also to generate new content. This content is not only text, as in the case of canonical large language models, but can be also data, can be images, can be speech. I think that one of the main point in our recent past that really deployed generative AI to the general public was November 30, 2022, when ChatGPT was released to the public, and everything changed. So all the interest, even from public sector, from the private sector, and research really was driven into pursuing research in large language models and generative AI. If you think about it, in only like 1 year from its release, more than 1,000 papers were released at the intersection between ChatGPT, so large language models, and medicine. And that's impressive if you think that even in less than 1 year, you had more than 1,000 papers, and thinking about all the review process and the time that it takes to do research and then publish, that's quite impressive. And also in the availability of large language models made some journals, some very important journals like the New England Journal of Medicine, which is the leading journal of healthcare all around the world, to open a spin-off which is concentrated on publishing research on generative AI and especially large language models. And also like new journals like The Lancet also did something similar. So there is a drive in research right now to pursue this kind of research because there is an interest in understanding how these tools can really shape healthcare in the next decade. Before talking about large language models, so what the technology is right now, I think we need to start with the basics. So everybody of us had some kind of interaction with some form of large language model. I think that everybody of us has wrote an email or used some like Microsoft Words, and you have like an auto-completion of text. So you write a sentence and then you have a new word that pops up. How does this word pops up? So the basic language model are simply statistical tools. So they know between a series of words, which is the most probable to happen after. So they predict the likelihood of words. So let's say I'm writing this email, I'm talking to John, I'm asking how's Paris, and then, yeah, I'm in Boston, the weather is. Of course, when you talk about Boston, the probability of being warm and sunny, it's very low. And the words that are most probable to follow are cloudy and rainy. So what happens is the autocomplete select the most probable word, so the word which has the most higher probability of happening after the previous one, and autocomplete it for you. However, the problem is that this basic statistical tool cannot handle very large contexts. So if you have a longer sentence, they may not be able to understand the context. So they will generate the new word based on the last couple, so like 2 words before the one that you're trying to predict. So let's say you have a more complex sentence saying the same thing, and I'll say, like, after checking multiple forecasts, despite what they said earlier this week, the Boston weather on Friday is expected to be rainy due to, and then I want to predict the next 3 words, which are sudden cold front. How do I do that? This is where the computational needs were met by using neural networks. And the way it works is that they don't take words as they are, but there is a process of converting words into matrices of vectors. What happens is that, so you have a long sentence and each word or couple of words become vectors. So they become number in a process called encoding. This space where these vectors are located is called embedding space. So you have a virtual space where you hold all the vectors that are used to train these models. And the important thing is that this space does not simply represent, there's not only like a simple word to number transformation, but these vectors encode also the meaning and relationship of words. Let's say I'm talking about the bank of the river, the vector would be totally different if I'm talking about the bank where I get money, even if I'm using the same words. Then when I want to predict the next word, there's a decoding phase where these vectors, where I predict the next probable couple of vectors, and these vectors are then decoded into words. And this is how I predict the next couple of words. So this is like very simply how this model works. What happens inside the neural network, so you have these computational tools in which you have your variables, so your x's, then you for each variables, you have your weights, so how much each variable impact on a prediction. You have some function that allows you to predict something. Then once you predict this something, you have a comparison with the ground truth. So when you're training them, you have a prediction, but you know already what's the real outcome. And then you retrain the model. So there is an update of how each word of each variables impact the prediction. And so the weights are continuously updated. So in this case, I will not have like my typical data set of numbers. Let's say I want to predict the salary of someone. In this case, the variables are the vectors. And I'm trying to predict other vectors. So I'm using words to numbers to predict new numbers that are then converted into words. When we talk about large language models, the thing that we have in terms of large is the number of weights. Okay, so when like simple language models used with neural networks have like thousands or millions of weights, with large language models, you have trillions. So by having these tools that have like trillions or billions of weights, you're able to generate new context, and also you're able to adapt the context to the large number of words. So this is what enables large language model to generate new context, to handle long context, and to provide some what we call generative AI tool. What happens usually with the training of large language models, which I know probably everybody knows about GPT, but there are like several others like Claude Anthropics, Meta AI, and Mistral. What they did at the beginning was that they scraped the whole internet. So they had data set containing all the information present in the internet in the form of text. And then they used all this text to train the first LLMs. And then the pre-trained large language models underwent a process of fine-tuning. So what they did is that they asked humans to grade or to provide feedback on how these language models provided a response, so a text, and then they used their feedback to update the weights. So they increased the ability of giving a certain response by having human in the loop that graded answers. And by doing several processes of supervised fine-tuning with this reinforcement learning pipeline in which the human provide information, they were able, like in several fine-tuning processes, to generate the large language models that we're using today. So I want to see like a large language model in action, like give you like a very simple example. Like I'm a patient, I'm someone. One day I touch my neck and I feel something. And instead of going to Dr. Google, I write to Dr. ChatGPT. Hey, I found something in my neck. It could be a lymph node. Should I be worried about like having lymphoma? Of course, this is someone who is a little bit hypochondriac. And then you have your ChatGPT that says, well, finding a painless lymph node in your neck can be concerning, blah, blah, blah. So it gives you like some information, like you should be aware of the size. Do you have other symptoms? Is it painless? Does it hurt or not? And then usually when they gives you like suggestions to go to the doctor. And if you think about it, this is quite impressive because when you like, if you write something like that on Google, the information can be very scattered and very difficult to compile all together. So they can give you like a set of information, clear, direct, and reply to your answer very clearly. The important thing is that now large language models are large multimodal model. What does it mean? So they not only handle text, but they handle other type of data sources. That could be images, that could be audio, that could be video. The process is the same. So there is an encoding in which instead of encoding text, they encode other type of sources, which can be images, audio, and text. And they are able to generate new images, generate new audio, and generate new video, as we've seen in the last couple of months. So I am the same person with the lymph node. And then, okay, I had an ultrasound. This is the image. Should I be worried? Should I still be worried? And so now ChatGPT, for example, is able to handle images, text, and they can provide like very useful answer, interpreting the images. Even if I'm not giving any info on the images, very low information, they're able like to check the size and shape of this lymph node, to check if there are like suspicious feature and everything. And they also like give you information if like any of the like worrisome feature or things that you should get, like you should check during an ultrasound exam, are not represented in this image. And that's quite impressive. And now I think it's time to, after this brief introduction on how large language models are trained and are used, to talk about their application in healthcare. At the moment, I could say that there are some pros and cons in terms of like, pros are more the way of which LLMs are already ready to be employed into everyday practice. And the cons are things that LLM are good, but may lead to some risk for the patient. So at the moment, they're very good to be used to do medical report generation and summarization, so they can automate work. And by automating works, they can reduce the physician burden. And we're going to see some data on that. And the third point that I'm saying here is more useful for private healthcare systems in which you need to bill. So you have some codes for the diseases, this code, and then bill to your insurance company. And there are a lot of problems with that. And the main cons at the moment is that because the information on which these models were trained, so the internet, this information is biased. So this bias may produce some misinformation when they use for healthcare reason, and this may lead to patient harm. Of course, there are some risk of privacy and data security. So if you are a doctor, we're making a pact with our patient in which we are saying to them, we will not leak your information to anybody. But if we put patient information on LLMs, what's the risk of leaking their data? Who gets their data? And the other thing is that I think it's quite important at the moment is that there is a lack of emotional intelligence. And I think that most of the patient wants someone who is empathetic with us when we're getting bad news, when we're getting good news, because this can increase outcomes. So let's check all of these points, and then we'll have a discussion together at the end. So let's talk about the first 2 points. So automating creation of report and some summaries, and the high potential for decreasing the physician's burden. So I think that every doctor, if there's any other doctor in the room, knows that when you're talking with your patient, it's not just simply talking about your symptoms. We check your vitals. We tend to know like what medication are you taking at the moment, what are like your anthropometric characteristic, did you have like any laboratory or imaging analysis. And at the end, once we collect all this information, we need to write a report. And this report has to be comprehensive of all the information that we got by talking to the patient. And I think that me and Professor Crocè know that this task can be very time consuming. So this is a recent paper published in JAMA, Internal Medicine. And they asked a lot of doctors, how many hours do you spend writing documentation? Most of the doctors spend more than like 1 hour a day writing documentation, with 26% spending more than 2 hours, 2 to 4 hours to writing documentation. So that's time taken from like talking to your patient and checking on them. And most of the doctors disagree that this time spent on documentation is appropriate. And they agree that this time spent for documenting stuff reduce the time you spend with your patient. And so what can we do with LLMs? There are a few studies on this particular task, and this is the most recent one published in Nature Medicine. And this group of researcher explored several LLMs, so proprietary, so like open source and closed source models. They use different methods that I'll be, in a couple of slides, I'll be talking more about them. So these methods add the medical guidelines to the basic knowledge of large language models. And the task was to write reports write summary on radiology, progress notes, patient healthcare, so the dialogue with your patient, and also patient health questions. What they did a clinical reader study. So they compared the report made by the LLMs with the report made by the doctors, and they try to quantify the harm. So they try to analyze how much misinformation was present in these summaries made by the LLMs. So they checked three things: so completeness, correctness, and conciseness. Completeness means does this report catch all the important information present in provided by the doctors? Is it correct? And is it concise? So it is something that goes straight to the point. Interestingly, when GPT-4 was compared to the humans, they provided more complete, correct, and concise report. And the extent of harm and the likelihood of harm, so the provision of correct information was more likely with LLM. So there were more errors when the reports were made by doctors. And this is just to provide you an example. So this is a radiology report that the authors reported in the paper. And as you can see, like in the top right part, in the summary made by the medical expert, there is a huge error by reporting the wrong brain lobe in which the hemorrhage happened. And you can think that may cause some mistakes if I'm like another surgeon having a second opinion on this patient, or if I'm going to have surgery. Maybe I'll read the report, I don't check the images, and I can, like, in another situation, could be like cutting the wrong leg of a patient. And this was the work that then inspired researchers to use LLMs in some ways to do the automated billing, so extracting information to provide diagnosis code. And this is very important. I work in the Yale, so I know how much important this is that if there are errors in medical coding, this may lead to payment delays, and this will increase the cost that the insurance will bill you, and increase denial. So if you have a wrong code, the insurance will say, oh, you're not getting this procedure. This procedure needs to be paid by you because it's not required. And this is, of course, particularly important because according to some studies, 4 in 5 medical bills have errors. So almost every bill has some error, and that may, on the long term, increase healthcare costs for patients. So this particular thing is kind of important in private healthcares. What usually happens is that it's not a doctor who provides the codes for billing. Some administrative people within the hospital read the medical note, and within the note, he or she highlights some terms, and from this term, he or she provide a code for the diagnosis. And of course, we can think that if you're not a doctor, if you're not a nurse, like this kind of information may be wrong, and you're not completely understanding the context of the notes or the medical note that you're reading. So what studies are doing right now, they're using LLMs to extract information. So this is, for example, a report of a patient presenting with chest pain. And you provide some instruction to the LLM, and the LLM knows how to read the medical note, and it extracts, you tell the LLM to extract information about the body part, so where, the chest, the symptoms, the shortness of breath or pain, and for each symptom, you have to extract multiple of them. So you know that for each symptom you have a code. And actually, it appears in a recent study published on New England Journal of Medicine that GPT-4 in particular and GPT 3.5 provide valid codes in almost 80% of the cases. And of course, 80% is much higher than 20%. So they will provide a correct bill, provide correct codes in almost like all the bills. So the opposite of what's happening right now. And this, of course, on the long term, it's beneficial for patients because they can have correct bills, reduce costs, and get the right treatment all the time. Of course, right now, despite they're being used a lot, there is a huge risk for misinformation and patient harm. As I told you before, I'm a gastroenterologist, and we've done a systematic review and found out that almost between 6 and 91% of the answers provided by LLMs in the context of digestive diseases is wrong. So there is some kind of misinformation, and we cannot accept this kind of broad range. And this happens because of three main reasons, because the doctors are using foundational models, so they don't introduce any guidelines. There is no standard report and strategies for report the methods. And also, when I'm saying that something is accurate, who am I to say that? Am I an expert? Am I a word expert or something? And we don't know what's the correct definition of accuracy at the moment. Is something completely correct? Is something like almost correct? We don't know. And this is of particular importance because LLMs in the field of medicine should abide to the 3H principle. So they should be helpful to the patient, they should be honest, provide honest information, and moreover, they should be harmless. Because if we have inaccurate information, we may harm our patient. And how can we increase accuracy? How can we make LLMs align with what we want? Through, let's say, three main strategies: engineering the prompts, adding some form of information as an external data set, or fine-tuning these models on medical knowledge. A prompt, so the prompt engineering process, is a process in which the user provides some instruction on how to interpret something, or provide examples. So I want to do you this task, I'm providing an example, so do as I'm doing, and maybe do better. The other thing that we can do is a process called retrieval augmented generation, in which we don't change the model. So we use the model as it is. And once we ask our question, there is an external data set of medical knowledge. There is a smart research. So we find within the data set the most similar part to the text. And then this text, this external text plus your answer, is used to provide the answer. So we bind the model answer to, for example, let's say guidelines. Another process is called supervised fine-tuning, in which the LLM is trained again on the guidelines, and then you have more fine-tuning steps in which you have the reinforcement learning that we did before. So we provide good and bad example and tell the model, please reply as the good example and avoid replying as bad examples. And this is, as I said to you before, of particular importance because what we want is to have data of high quality. And the data on which LLMs were trained is data of very low quality because they scraped the net and took text as it is. And one of our main questions was that can we create like an LLM-friendly version of guidelines that they can extract information and provide information accurately? And we designed an ablation. We designed an ablation study because we found out that especially for images or graphical elements in the guidelines that always contain crucial information, only 16% of the time this information was extracted correctly. So we were introducing some kind of bias, while for the text, all the time it was extracted and interpreted correctly. So in this ablation study, we did some experiment. So we converted everything into text. We manually converted the images into text as well. We provided a few examples in a process called few shot learning. So we provide a few examples on how to respond. And we found out that in the last 3 experiments, so when everything was converted into text, and when we provide information on how to interpret this text that we formatted, the accuracy of replying to questions related to medical guidelines was on the 96%. So almost all the time they provided the correct answer. And we also farthly explored that by having the European expert on hepatitis C, drafting the questions for testing and also evaluating the answers. And these were the author of the guidelines on hepatitis C, and we evaluated two things: accuracy using a point scale. So we provided 10 point in 0, very low accuracy, 10 high accuracy, or a binary grading, so completely accurate versus everything else. But also we wanted to know about clarity, so the relevant information that can be easily understood, straight to the point, explicit, and free of ambiguity. There's an error in this image. Okay. I'm sorry. Substantially, what we found out is that compared to the baseline, RAG and supervised fine-tuning, so when we introduced guidelines, the accuracy went from 6.4 to almost 10. And also, it's very easy to create your own chatbot with medical guidelines if you know how to format them and how to use retrieval augmented generation. This is an example of a very simple chatbot that can be deployed easily in every hospital setting. And as you can see, this is, for example, a patient asking information if he or she can be considered cured for HCV after doing treatment with antiviral agents. And then the models, knowing the guidelines, replies, yes, you have to meet some criteria, you have to be like confirmed to be negative for 12 or 24 weeks after the last dose, et cetera, et cetera. And this can be very helpful, not only to doctors, but also to students who want to know more knowledge and maybe have some questions that it's maybe difficult to reach on guidelines, and this way provide a very fast way of knowing things and reduce time to get to the knowledge. A problem with having LLMs in healthcare is that at the moment there are several LLMs available. So there is ChatGPT, there's GPT from OpenAI, there's Meta, there's Llama from Meta, Claude from Anthropic, et cetera, et cetera. There are like hundreds at the moment. So how can we select the LLMs that is most useful for our purposes? And especially if we think that grading all these answers, which are not like 1, 2, 10, but we're talking in the time, in the thousands of answers, very time consuming. And therefore, we can say that selection of the best LLMs for our purpose can be very intensive in terms of human labor. And while I tell you a possible strategy, I want to talk about the embedding space that we spoke before. As you can envision the embedding space as a universe. Within the universe, you have all these vectors, which can represent the stars or planets. And each of these vectors represent a word or a couple of words. However, having some form of similarity, text similarity to one word and the other can be very complex by having this very complex multidimensional space. So we need first to reduce the space to something that can be analyzed, and then try to unify this process. So one solution could be the process of exploring cosine similarity. Substantially, all the vectors get represented into the surface of a sphere, if we're talking about a spherical representation. And then there is a center. So we can see we can think it as the solar system and all the planets. And then we measure the cosine of the angles comprised by the two vectors. If we have a cosine proximate to 1, the words or context is similar. If the cosine is proximate to 0, the words are completely different. For example, ball and crocodile. But we can have like cosine of -1, in which we have like the same things that could appear similar, like France and Paris and Rome and Italy, but they're being sent in the complete opposite order, like state and capital. And we kind of explored cosine similarity to test which LLMs is better for our purposes. And we generated several clinical questions on gastrointestinal bleeding. We asked the 5-word expert on the topic to provide their free text answers to these questions, and we labeled them as golden labels. So they were from North America, Europe, and Asia. And we tested multiple settings, so the baseline model, the retrieval augmented generation, the supervised fine-tuning, and 2 doctors, one was I, graded all the questions from each of these several settings. And we also tried to validate the text-to-text similarity by using like an unbiased benchmark, which were questions from a self-assessment test of the American College of Gastroenterology. So what we have here, we have several models. We have the cosine similarity, so we compare the text of the responses provided by each model and the responses provided by the expert, and then we provide a rank of the models, and then we want to see if the ranking provided by the automated way is similar to the human grading or is similar to this benchmark testing. And very interestingly, we found that the unsupervised process selected the best model as well as the human graders, or as well as when it was tested on the benchmark. And this model was GPT-4 with the guidelines integrated. And also interesting as well, the as you can see in the last images, there is a green dashed line which represent the average human score. GPT-4 plus the guidelines responded better than humans. So we can have way to increase accuracy and to provide accurate information. What about privacy and security? So you have to think as LLMs as 2 ways. You have local LLMs, so these are LLMs that you can load in your local setting and you can employ locally. So every conversation is held locally, and the risk of information leaks is mainly dependent on the security of your local setting. Proprietary LLMs instead, like GPT-4 from OpenAI, every conversation is stored into the LLM's company. So like all patient information that you're putting there is linked to the company, and they have it. However, in the past few months, there were some agreement between healthcare systems. For example, Epic from Microsoft is the most spread healthcare system in all the United States hospital, and they opened a partnership with OpenAI, which is also linked to Microsoft, to host their models locally. So they have like smaller GPTs in their systems, and you can query them, and this information is not linked to the company. And that's quite impressive, and that's going to happen a lot, especially in the United States or in Asia, in the next few months. So we will be able to test these LLMs into real-time clinical application without risking the leaking patient information. And then I want to talk about the last thing, so the lack of emotional intelligence and empathy. So, of course, empathy is important, and it is the basis of a good patient-physician communication. And empathy comprises not only empathy per se, but like several other things like attitude, competency into like your knowledge, being empathetic, being able to communicate well, being able to explain things correctly, and your behavior, the behavior you have with your patient. There are studies that confirms that when the doctor is more empathetic, there are better engagement with the patient. There are better outcomes, and also patients are more driven to follow treatment. A lot of the time, we lose patients on the follow-up because they don't want to follow treatment. They don't care, and then you meet them like after a couple of years, and they have a worse condition that could have been like easily avoided if they were treated, if they followed the treatment that we recommended previously. So we don't know if LLMs are using prediction tools, or so if they're like stochastic parrots, so they're using the same wording that we're using of they effectively have empathy. But there are some studies that are comparing the responses of doctors in the same context with LLMs, and it appears from these images that LLMs tend to have a more depressive tone compared to doctors, so they tend to be more negativistic to their patients, so be more dramatic in terms of outcome. And Sometimes they are, so the plus 6.4 point, but they also tend to be like more understanding. So they try to tell you, okay, this is wrong, this may be wrong, but don't struggle, you can solve things, so they can help you. And we've tried something in a project called Empathy GPT using IBS, a kind of disease, functional disease in our gastrointestinal tract. And we used a GPT model with the guidelines integrated with some instruction on how to be empathetic based on psychology and psychiatric books. And we used the responses by the doctor to give them a grade. How good were you with your patient? And then we compared the results with answers provided by LLMs. Interestingly, 90% of emotions reported by the patients were correctly identified by the models, and they were able to grade the correct emotions in medical students 85% of the time, according, of course, to human grader, who also reviewed the model's responses. So at the moment, we don't know if they're just stochastic patterns or if they're empathetic, but we have ways of making them respond as we want, to be more empathetic. And we know that sometimes, like at the end of the day, after seeing like 30 patients, you're not empathetic at all. What's on the next corner? What's going to happen in the next few years? We're going to have a thing called ambient AI, probably. So something that listens to us all the time we're with a patient. And when we ask questions, there will be a form of large language model that will listen in real time to the patient conversation and have access to the patient records. So they will have all the information that we have and could be able to give real-time feedback on the conversation that we have with the patient and tell us, oh, maybe you forgot to ask this question. Please ask this information to the patient before sending him home or before treating him, so they can give up warnings in real time. And this will be based, of course, on the fact that they have guidelines and instructions. They will be able to produce summaries in real time and create billings automatically, so they will save a lot of time. And they will be able probably to produce real-time decision as well. So we are talking to a patient, and automatically we'll see on our like local computer, okay, for this patient, treat with this medication at this dosage, and or admit the patient, send him home. And this can produce also like real-time conversation with the doctors, because they will know like all the changing information from the electronic health record in real time. So if any labs changes, or if you do like any other medication, the information can be changed and provided real time. And another problem is the liability. So in case I create a very automated healthcare system in which LLMs are integrated, if there's a mistake, whose fault is? It's fault of the doctor, who's the LLM, it's fault of the hospital that deploys the LLM, or the fault is from the LLM company that deployed the LLM into the healthcare sector. And we don't know. There are no laws at the moment, and our legislators are not at the moment taking care of this. So we will have like a huge low gap in what will happen very soon, and we don't know, and we have a huge risk of harming patients, because our technology, which is probably not ready at the moment, without the correct safety net, will be deployed, and mistakes will probably be made despite our best effort in making it as good as possible. So thank you, everyone.
Thank you, Mauro, for your clear presentation. And now I open the questions time. There is anyone over?
Hi, thank you for your presentation. It was really interesting. I have a question, maybe I missed it. So you basically worked on ChatGPT, right? I mean, among the other, or you work mainly on open sources, large language models?
We worked more on proprietary large language models, so like Claude from Anthropic, or like GPT from OpenAI, but we also exploit some open source LLM like Meta's.
Because my question was about this proprietary model. So is it your research open, or is it owned by the companies, the private companies? Because my concern is that, like, we can use ChatGPT because OpenAI allows us to do it for free. But what if one day they're gonna raise their paywalls and not make it available for the common man? And also, you know, it's kind of blackmailing hospitals. So I let you use this, I let you become dependent of this because you like it. And now it costs millions and millions of dollars. And if you want to use this technology, you have to pay for it. Isn't this a risk of, you know, engaging with this kind of private company in doing this kind of models? Aren't we giving them too much power in this sense?
We are already doing that, because the research we do is not using like the ChatGPT version, but we have a interface in which we code all of this. So there's some like code where you have like the external data set, and this is extremely expensive already. So you pay for each token, like for each smaller number of words you pay, you pay an amount of money. So it's already very expensive. The problem is that a lot of the research is being done on OpenAI GPT because it's the best one. But there are a lot of companies that are trying to do their best. So I don't have an answer for you at the moment. I think that this the corporate factor will probably bring new companies that are better. For example, as you know, like all people are leaving OpenAI at the moment and going to Anthropic. So probably Anthropic would be better. I think that most of the research need to be done on open source model, like for example, Meta's or Phi from Microsoft. The problem is that they're not good as we expect. So we don't have as good results with these models, despite being free. So they are completely free. You can use them for free. And I don't think they will make people pay for it. But the property, of course, they want to make revenue because they spend a lot of money to develop this method.
Maybe, you know, OpenAI or whichever company becomes aware of your research and trying maybe to fund either their own or trying to buy your data or doing something similar and sort of cut you off at some point. Because I've been working with large language models. I know how ChatGPT like works more or less. Because I work in a company, we were using it, so we were paying for tokens and whatnot. And my fear with this kind of company is that they are allowing, right? And one day they might tell you, okay, this ain't working anymore. And the second concern is that they never released the architecture of ChatGPT. So also, I think there's an issue if you want to use this kind of technology, especially in Europe, in hospitals. Because, you know, the GDPR, it's already hard to work with this kind of technology if you know the architecture, but that's another level of black boxing. So isn't all of this problematic for a transparent and fair use in medicine? We were talking about liability, accountability. Isn't all of this like building on the problem rather than... Like, I mean, this research is very interesting. My point is this being applied at some point, or are there limitations that will make this not as spread in the use as it should be, as it would be nice to?
Yeah, so you made a good point. So I think applying this research into real life clinical practice would be much easier in the US because you have less regulations. I don't see anytime soon being applied in the EU because we have very strong regulation, especially on the privacy problems. I think that despite the fact that we are now building the problem of having all these tools, this kind of research need to happen. And if we, in public institution or like semi-public institution like Yale does not do it, OpenAI will own all of it. So OpenAI, Claude, and in these cases, we will not only have like models that we don't know how they're made or like the weights of each model, but we wouldn't also know like how to improve them. So I think that we need to keep on doing this kind of research, but at the same time, doing that onto open source models. So we're waiting for open source models to catch up with the OpenAIs or Claude, and then I think we will be able to solve this problem. Of course, they don't own our research. They could like make us an offerings, and I don't know. I don't know what to reply. It depends on the offering, of course. But yeah, so they know, they are aware of all the research being done, especially if it's published on like important journals. You're welcome.
We have, I think, more 10 minutes of questions if you want to. Is there any other question from the audience? And then on the...
Thank you. Just to know, you mentioned these large language models, especially in the healthcare, that must be trained with data of good quality. Could you please give us some examples of, well, how to acquire this data, what this data would be?
Okay, so let's say I'm writing this LLM-friendly version of the guidelines. It should be something that it's completely text-based, because the vision model at the moment are not good enough to extract information from tables or flowcharts, and it need to be like structured in a coherent way. For example, you have like in a text, you have like several paragraphs. So what we did is that we have like paragraph 1, something very stupid actually, so it's not something that complex. The paragraph number, the paragraph title. So each section had the specification of what it is. Is it a recommendation? Is it talking about evidence? Is it like the main topic of the paragraph of the text? And then we provided like a correct instruction. So you will find the main topic of this section into the paragraph title or the paragraph number. You will have the recommendation, so the thing on which you should base your responses, into the recommendation section, or the evidence. So what made the expert provide this recommendation into this section. So that's how we made it. I don't know how to respond in other fields, because I know that there is a lot of work being done, especially in the economic fields and the financial. They want to automate investment using LLMs. So I'm not quite confident that they're able to do that, because they would need to analyze a complex graph. And of course, this kind of research goes where the money goes as well.
The first on the back, and then further.
Hello, thank you so much for such a wonderful talk. My question is more related towards the ethical concerns of such research. You said that for training the LLM, the model scrapped data from open source data that is available, data sets that are available online. Obviously, those data sets are consented from patients when they were taken. But the data that you are putting in as a test data set, are those like consented, or what's the privacy wall for those kind of information?
So the thing that this company do is that they scrape all the net. So they go like journal pages, whatever is free. Everything that's free on the internet, like everything that's available, they take it. So at the moment, they've took everything. Everything is there. The problem is that this information is biased. Okay, because let's talk about like modern medicine. Modern medicine is directed towards white males. Presentation of disease into females is different. This model encompasses the bias that's present in our current knowledge. So they replicate our biases. And regarding the problem that I think you were hinting is that they knew, some private companies knew that they also took, the LLMs companies took information from private data sources without telling who's and where. So yeah, what we do is that we take information that's publicly free or that's we got consent from the patient. So we're not taking any proprietary information without consent. And like the guidelines are public, so everybody can use it. They're made to be publicly available and be used by all the doctors. So there is not usually like a paywall for the guidelines. For the journal articles, yes, there's always like, there's a lot of the times a paywall, but for like guidelines, there's not. So we're using like free sources and not proprietary sources. So we're not infringing copyrights.
Thank you for your presentation, really interesting. You mentioned before the cosine similarity
Yes.
for search the different about different sources of text. What do you think about these metrics in the medical field? So in the medical text, it works, it doesn't work?
Okay. So first of all, let me say that Simone was the question and Professor Miloš Ađević are like two of our collaborators in the Trieste. So we're doing like a collaboration with Yale and Trieste, and they're our main collaborators here in Trieste. And Simone pointed out a very important point. So when we think about medical knowledge, so if you think, let's say they got all the information from the internet, so they're taking everything. The medical knowledge is just a small section of this knowledge. So let's say I'm talking about esophageal viruses, so some veins enlarged in the esophagus, and I'm talking about esophageal ulcers. The semantic difference is too similar within a smaller a smaller space in the embeddings. And this is why they may not work properly, but you can fine tune also the embedding models and make them biased towards medicine and use them a little bit better. They're not perfect, but we've seen some good signals. So I think that we will have like some more interesting and more refined version in the next future, because I think this is the next step. Thank you, Simona, for your question.
Are there any other questions? No. The second line,
Yes.
please. Was before. Sorry, but I follow the.
Thank you very much for the incredible talk. What do you think, in broad strokes, the timeline is in the future for the widespread use of ambient AI, maybe first in the US and later on in Europe and in general? Do you think the rate of progress is going to stay constant? It's going to increase, decrease?
So the increase of you mean deployment, like employing this kind of technology, or the improving time? Okay, so the deployment can be very easily. So it depends on the hospital, it depends on the regulation. And I think there is an interest in money-driven healthcare sectors like the US, in which they want to get to pay less money, so they will introduce as much as automation as possible. Regarding the improvement, I think that all of it depends on the data. Now they've exhausted all the data. So the only thing that they can improve now is the number of parameters. So making this model more and more complex, but they've already exhausted all the data. So they can only improve now on the terms of how complex, so the computational part of the LLMs. And on that, we don't have any power because they have all the money, all the power. And I think they will make some improvement in the next future, but I think we're like almost as a plateau right now. And maybe there will be some breakthrough in the next few years on something. Probably they'll improve the architecture, or they'll make it more able to use whatever is already here and improve the generation process. I don't know if it will be applied easily in the European Union. I'm not confident as much.
Last 2 minutes.
I have a curiosity, like could these models can be taken as like second opinion for the patient? So So it is something, I don't know. I want to know your opinion on this. And secondly, about legislation and policies regarding ambient AI, if it comes into market. So are there people working towards creating some legislation or policies for ambient AI? Because they are there listening to the conversation between the physician and the patient, which is confidential. So yeah, I would like to know about that. Thank you.
So regarding the legislation, they're doing something in the United States. They're not here in the EU. I think that what will happen, because the legislation cannot catch up with the technology at the moment, they will create waivers. So they will create this legislative gap. They will tell you, hospital, want to employ this technology, you need to have all your patients sign waivers. As soon as they do that, that's fine. And on the using them as a second opinion, people are already using that. So are doing that, and also NVIDIA artificial intelligence are using like LLMs to have patients followed up at home. For example, they are discharged from their surgery, then they go home. There's these virtual LLMs that ask you, how are you? Do you have any symptoms? And all this is reported to the doctor or the nurses that are taking care of you. So yeah, it's already happening.
So I think we are, no, we can also have 15 minutes. Okay. So another question there.
Compliments for your talk. One curiosity regarding the level of acceptance of this type of technology, the difference of the level of acceptance of this type of technology within the medical doctors, differences between your experience in the States and in the Europe, considering also interoperability with medical health records. You mentioned Epic, and in Europe, in Italy, in different regions, we have different medical health records, et cetera, et cetera.
So the first part of your question, I think it's directed toward the trustability part. So how do doctors trust this tool? How can we make them trust them more? I think the only solution is training them. So doctors need to be also trained in AI. You can have doctors in the 2024 that are not knowing what AI is, how does it work, and how can you use it. You will be obsolete in a couple of years if you don't know those knowledge. So I think this is the first thing. Regarding the standardization, of course, there's a huge problem, because if you have like LLMs trained on data, let's say in the United States, all hospitals have Microsoft Epic. So all the information is coded in the same way, and you can have Epic query patient information from all over the hospital in the US and have the same standardized data set that you're going to use to fine-tune your models. In Italy, for example, you have in CLG2 here, in another region you have another one and another one. So all the intrinsic coding of the patient variable is completely different. So that will be a problem if we want to train these LLMs on Italian patients, or on French patients, or on German patients. So that's a problem. That's a problem, and I don't think it can be solved easily without legislators being aware of it and providing solutions. And legislators are not doing it at the moment. So I'm sorry.
I think we have to speak also on data quality, because this is a great problem for me. What do you think about it?
Yeah, so the quality of data. So I'm having data from patients, and this data is collected differently. Like the patient is admitted to the hospital, and then labs, so the labs like hemoglobin, CBC, whatever, is collected. In hospital, is collected within an hour. In the second hospital, the protocol say this data is collected within 5 hours. So the measurement is not the same within different hospitals. So you're taking data from patients that have the same disease but at different moments, and this may affect how the LLMs understand or make decisions or interpret them. I think that, for example, in the US, they have protocols for everything. So, you know, if a patient gets to the hospital with sepsis, the protocol is the same across all the US. So they will know that these labs need to be taken within 30 minutes of the patient getting into the ER. The CT scan needs to be done within 2 hours. So they have very strong recommendations. And yeah, so I think that, for example, the US for this is more prone to develop new technologies because most things are standardized. And here we do things differently, even within the same hospital. So yeah, that's a problem.
The other question?
This is more of a curiosity.
Yes.
Like, I'm assuming that these models are huge and very energy consuming. So in a future where we have to pay a lot of attention to the carbon footprint, is there a way, and if this gets, you know, widespread, a lot of hospitals are using it, so there's a lot of CO2 consumption, because we know that the huge servers that run these are very consuming. So are you already thinking about a possible way to shrink these models and maybe be used either offline and also like in a smaller setting so that the carbon footprint can be reduced because the models get smaller, or is it maybe future work or something?
Okay. So to reply to this question, I'll provide you an example. To train the latest 405 billion parameters from Meta's, the Llama 70B model, Mark Zuckerberg make a comparison of taking the power from a power plant, a nuclear power plant, for 3 or 4 days to train the model. So this complete power was used to train the model. I think that one of the probable scalable solution is to have Microsoft doing something for a model called Phi-3, which is a smaller model, but the data is very curated. So the data used to train this model is very curated. So you can, they're saying something like if you have smaller models, so they use less energy to training and to maintain because they need less cooling and everything. You can have like a model that consumes less energy, which is as good as the bigger model. And so they're trying to scale the quality of the data to make it as good as possible with less parameters as possible. And in that way, probably it will consume less. And I think we also need to think about how these models will reduce the footprint when we're using them for some tasks. Let's say we're using them to improve energy dispersion from some like an facility that produce energy from gas sources or everything. So I think that in the short term, they will use a lot of our powers in terms of electricity and everything. On the long term, they will be able to automate a lot of process and so reduce the amount of energy that we use for other tasks. So I think that's we're trying. I think the sector is trying to balance the amount of money you spend to keep them and the amount of money you can save in terms of energy to do some other task automatically.
There's a last quick question about whether or not these models, for most part, have access to copyright-covered editorial works, whether it's under peer-reviewed journals, like for ones, some of which you cited, or under Google Books and data like that, if most models have access to that information as well.
So, for example, OpenAI is officially saying that they did not took any information from, let's say, Nature papers that are under a paywall or information from the New York Times, which is under a paywall, but general adversarial attacks found out that they did. So they're just not saying it, but they're doing it because there are like ways of going behind the paywall without paying. So that's a problem. And that's why I think a lot of, for example, journals, I think you've heard JEDI and OpenAI talking a couple of days ago, they made like La Repubblica available to OpenAI. So they will have that kind of knowledge in their data set for training or fine tuning or extracting information. So I think the smart move from like news journal would be to have a consortium with these LLMs and allowing them to get their information. Maybe ask them, you will pay like X amount of money to get X amount of information, because if they don't do that, they will take the information and not pay. So I think that's the move they will make to avoid them for like paying this company to pay for the content and deploy it.
So thank you everybody for the attention. Thank you to Mauro. And also thank you because you ask a lot of questions. It's quite, I don't know how to say it, but positive. Thank you so much.
Thank you, everyone.